Hey, what's up, Ziguanas? This is day 21 of the 30 Days of Zig Coding Challenge. Join me as I apply over 2 decades of professional programming experience and around 15 years of code teaching experience to master a new programming language. The name of the language is Zig. My name is Dusan. Welcome to Ignited. So today, basically finishing the third week of coding in Zig, learning Zig. And today on the menu, I have built-in functions. Yeah, first of all, just like I would like to apologize that I am starting this live today a bit later than usual. I literally returned to my home, so I was in a different city entire day, so I've just arrived. Sorry for that. And back to built-in functions. So there are many of them. I will try to go through all of them. I don't know how much time it will take. If I make it in, let's say, under 1 hour, then I will go through all of them. And the idea is not to learn and memorize all of them by heart. Hi, Robert, how are you? Hope you're having a nice night. So I was saying the point is not to, the idea is not to memorize all these built-in functions. It's just to see what's there and kind of get the larger picture. And this is also what I do when I teach my students, no matter the language, so Python or it doesn't matter. I always show them some functions bit by bit so that they don't get overwhelmed. And if I show them more, I say that this is just like for the wider picture. So not that they have to memorize everything, just to understand what is there and what can be done. That's the idea. So let's start with built-ins. Built-in functions are provided by the compiler and are prefixed with the @ character. The comp time keyword on a parameter means that the parameter must be known at compile time. Okay, that's something that we already used a few times ago. Let me see what Robert says. Programming my side project, having a cold one in your stream, great experience. Yeah, it's very interesting, so I like it. Kind of like if I weren't streaming, I would probably postpone a lot of these things. I would do them like instead of in 30 days, I would do this in 3 months or something. But if I say it's 30 days, then I have to show up. So that's the thing. So it's kind of like forcing me to be regular. And I do enjoy like this kind of thing, communicating with people. And first of all, getting to know the community and also to have some feedback. And it's great, for example, that you're here and I ask you questions. So you help not only me, but also other people that are here in the stream when they watch even later. So they will see some useful things they will get. So this is like if I were doing this offline, let's say just like record video, maybe make it more compact and then publish it instead of live streaming, then I would miss this part. And this is like what I really like, this communication aspect of it. Okay, let's see the first built-in address space cast. It receives pointer of any type. Okay, I guess this is what it returns here. So it's just a signature, they just say what it returns. Converts a pointer from one address space to another. Address space. Okay. The new address space, yeah, they literally call it address space. And the new address space is inferred based on the result type. Okay, this is inference. Interesting. We went through this. Depending on the current target and address spaces, this cast may be a no-op, a complex operation, or illegal. Oh, so it can be anything. If the cast is legal, they mean like this cast, this part of it can be no-op. It will be then done in compile time, right? For sure in no-op. But then if it compiles it, it can be that it compiles to something that has to be done as a runtime instruction. or illegal. Okay, if the cast is illegal, if it's legal, then the resulting pointer points to the same memory location as the pointer operand. Okay, so the result is pointing to the same like the operand. Okay, it is always valid to cast a pointer between the same address spaces. Okay, then let's see the next one. Let me first see what Robert said. Good motivation. Also, I might have left you something on GitHub. Had a bit of time today. Oh, great, I will see it. Yeah, I literally got back home, so I didn't see anything. I will definitely check it out. Thank you. Where were here? Add with overflow is the next one. And this one has two parameters, A and B, which can be any type. And it returns a struct, which basically invokes before it returns the struct, it will invoke another built-in type of for the same inputs. So it's passing them to the type of, and then the UI. So this is unsigned integer 1 bit long. So this is what they will return. And this is add with overflow. Okay, let's see what they say about it. Forms A plus B and returns, yeah, but yeah, it's named that. And returns a tuple with, so yeah, I said struct, but because it's anonymous struct, it's a tuple. The same thing. So it returns a tuple with the result and a possible overflow bit. So this is, I guess, 1 if there is an overflow, and 0 if it's not. Okay. Align cast receives a pointer of any type, pointer to any type, probably better to say. It returns any type. Pointer can be, this is like, if I remember, like a single, how do they call it, single, I forgot there is name, like the one that has only one, referring to a simple thing. Then this is an optional, and this is a slice. So this is a multi, how they call it, multi something. I forgot the official terms. Changes the alignment of a pointer. The alignment to use is inferred based on the result type. Align cast. Okay, a pointer alignment safety check is added to the generated code to make sure the pointer is aligned as promised. Then in the same group of built-ins, align off takes this time comp time. So the type as parameter, and it returns comp time int. And this function returns the number of bytes that this type should be aligned to for the current target to match the C ABI. Yeah, so this is for integration with the C language. When the child type of a pointer has this alignment, the alignment can be omitted from the type. So the child type of a pointer, okay, has this alignment. The alignment can be omitted from the type. Okay. Yeah, so this is, again, I don't intend to memorize all this, just to understand at least as I go. And then when I will need to use them, I will try to remember that there is something like this if I need it. Const assert. So this is an example. Okay, const assert equals import std. Okay, this is just like the import. Time assert the pointer to u32 if it's equal to the pointer to align of u32. Okay, so they force the type to be u32 during the compilation, and then this will return, right? This is the, why they have to, just a second, oh no, this is the align of, and this is the align. It's a different one. So the align has these two parameters inside, and one is wait, not parameters. So this is the integer comptime int that is here. So the value and then the type. Okay, and then there is a star align pointer align, and they want to see if it's the pointer to U32. Okay. The result is target specific compile time constant. It is guaranteed to be less than or equal to size of t. Okay, then this one I used already, but let's go through it. It receives comp time t type and an expression, and it returns the type, the same type. Not actually the same. Yeah, the same. So here you say which one you want to cast it into. So, or coerce, to be more precise. Performs type coercion. This cast is allowed when the conversion is ambiguous and safe, and it is preferred way to convert between types whenever possible. Okay, yeah, I use this one, but when I read it like in abstract form, I kind of forget the order. That's why I got confused for a second, but yes, it's always the type here to which you cast, and then you have the expression. Okay. Atomic load. Atomic load has 1, 2, 3 parameters. So comp time t type, pointer, which is a constant pointer to the same type, and then comp time ordering, atomic order. I haven't seen this one so far, so not sure what it is. This built-in function atomically dereferences a pointer to a t. So you receive a pointer to something and then you dereference it, that type, and returns the value. T must be pointer, a bool, a float, an integer, or a pointer, a bool, a float, an integer, or an enum. Okay, enum. Atomic order can be found with import std built-in atomic order. Yeah, so this will require a bit more digging. Then atomic removal. So this is load. This is maybe the opposite one. Let's see. RMW, so remove probably. Atomic remove. I'm reading it remove for now. Comp time t. The same inputs like before. Oh no, it's not the same. This is the same, the ordering. The last one is the same, but they also have additional comp time OP operation, or let's see. This built-in function dereferences a pointer to a t and atomically modifies the value and returns the previous value. It must be a pointer, a bool, a float, an integer, or an enum. So these two types. Atomic order can be found. So they already said that, I think. Yes. They're just repeating, and they are also adding the atomic removal. Okay, atomic store. Similar signature. Like the first one, actually the same. Here there is the return value void. I haven't paid attention here to the... So here it's t, the previous was t, and here it was t the same. Okay. Because it was too long, I didn't even check the end of it. So atomic store, void is the returning point, the returning type, the same input like the first one. Atomic load. This built-in function dereferences a pointer to t and atomically stores the given value. T must be, so they're very related. The same restrictions for type. Okay. So stores the given value, modifies the value, returns the value. Okay. Okay. Just wanted to recheck. Then bitcast receives the value of any type, returns any type, converts a value of one type to another type. The return type is inferred result type. asserts that size of type of value is equal size of destination type. So here they have to use the type of because it's a bit dynamic. And what else it asserts? It asserts that the type info des type not equal dot pointer. So it cannot be a pointer. Use pointer cast or pointer from integer if you need this. So if you want to bit cast to a pointer. Can be used for these things, for example, convert F32s to U32 bits. So yeah, that's why they call it bitcast, because they are preserving the size. So it's not about the type like as built-in, but it's more about just like saying, okay, this sequence of zeros and ones, now I'm going to consider them as something else. Works at compile time if value is known at compile time. It is compile error to bitcast a value of undefined layout. This means that besides the restriction from types, which possess dedicated casting built-ins, enums, pointers, error sets, bear structs, error unions, slices, optionals, and any other type without a well-defined memory layout also cannot be used in this operation. So the memory layout is important. Bit offset off. Let me just see how quickly, and let me first see the messages, what Robert says. Remove stands for read modify, it's not remove. So RMW stands for remove. Sorry, I keep insisting it's a remove. Read modify write, if I'm not mistaken, not 100% sure though. Okay, thank you. And let me just see quickly how far. So this is maybe I cannot even assess it, so many of them. So let's say 10% maybe. And it's been like 15 minutes or more. So I will not be able to go through all of them if they're the same amount of explanation, if they have the same amount of explanation. Okay, let's try and see how much I can do. Bit offset off, comp time t, comp time field name, which is this type. So it's a constant slice of U8s. Yeah, so I want to say here, not that I don't see the or where it was, it doesn't matter. So I meant like this other atomic order I haven't seen before. So here we have two parameters, comp time type and comp time constant slice of U8s, and it returns comp time integer, bit offset off. Returns the bit offset of a field relative to its containing struct. So this one here. For non-packed structs, this will always be divisible by 8. For packed, non-byte, so yeah, because in packed they can say U1 and U2 and that's it. So non-byte aligned fields will share a byte offset. Yeah, because it's about yeah, so I mean, they cannot make the same if they're packed. They will be regular, but they will have different bit offsets. Okay, yeah, that makes sense. Bit size off. So it just receives the comp time t, returns the comp time int, so a number again. This function returns the number of bits it takes to store t in memory. Cool. Bit size off. Nice. If the type were a field in packed struct union, the result is a target specific compile time constant. This function measures the size at runtime for types that are disallowed at runtime, such as comp time integer, and type, the result is 0. Okay, makes sense again. Let me see what Robert says. Branch hint is cool, not used often, but when needed, absolutely glorious. Let's see what is it about. Now I'm curious even more. It receives a hint, which is of type, again, not seen this before, branch hint. Doesn't return anything. Hints the optimizer how likely a given branch of control flow. Aha, this is, yeah, so it makes sense. They can name it branch. So if and switch right branches, maybe even if you have continue and break in while, and or is to be reached, how likely. So is it like a percentage, like probability, or how do you hint? So you have branches. Yeah, I would have to research it to see what is actually this thing. So how it hints, what is it like, how it quantifies. Can be found at OK. This import, this function is only valid as the first statement in a control flow branch or the first statement in a function. OK, breakpoint. Nothing is returned. This function inserts a platform-specific debug trap instruction, which causes debuggers to break there. Aha, so yeah, breakpoint, this is for debugging, of course. Unlike for trap, I haven't seen this one yet, so it's probably later, because this is alphabetical. Yeah, trap is later. So unlike for trap, execution may continue after this point if the program is resumed. Yeah, this is literally like in ID, when you put breakpoints and then you actually ID is using this aspect. Better to say like that. But I meant to visually, like in ID. This function is only valid with function scope, mal add, comptime t, and then it has a, b, c, three things that are the same type, return same type, fused, multiply add similar to a times b plus c, except only rounds once, and it is does more accurate, supports floats and vectors, so floats. Mal add. I thought it's going to say like multiple time, add multiple times, but this is like multiply and add. That's why. So this expression here. Okay. Byte swap. Operand is any type, returns t. Type of operand must be an integer. Okay. Integer or integer vector type with bit count evenly divisible by 8. Yeah, because they want to swap bytes. Okay. Operand may be an integer or vector. K swaps the byte order of the integer. This converts a big endian integer to a little endian and converts a little endian to a big. Note that for the purpose of memory layout with respect to endianness, how do you pronounce this, the integer type should be related to the number of bytes reported by size of bytes. Okay, this is demonstrated with u24, size of 24 equals 4, which means 4 bytes. But this is not, so this is going to be 3, which means that u24 stored in memory takes 4. Okay. Yeah. It makes sense. And those 4 bytes are what are swapped on a little big endian system. On the other hand, if t is specified to be u24, then only 3 bytes are reversed. Okay. Now it makes sense. Bit reverse. And this was byte swap, and this is bit reverse. Okay. Integer any type returns t. Type of any type accepts any integer type or integer vector type. So similar like above. Reverses the bit pattern of an integer value, including the sign bit if applicable. So it preserves. No, it reverses also the sign. Okay. Bit pattern including the sign. So I guess it reverses the sign as well. Let's see. For example, 0b. Okay, so 101101110. This is in decimal. I will trust them. This is 182. And I8 minus 74. Again, I will trust them that this is, so yeah, it's minus definitely because this, how they call it, most significant bit is 1, so it's negative. Becomes, so they basically reversed everything, so including the sign. So now this is positive 109, and also here. Okay, let me see what you wrote, Robert. You provide hint none. Likely, unlikely, cold, unpredictable. Aha, so it's like these let's say keywords, that not the keywords, but it's not a number, it's let's say a word that explains the level. Unpredictable, when they mean what they mean can be found in stddoc, which tells optimizer that something will happen often, rarely, and optimizer makes code fast. Cool, cool. Of course, if you don't lie, yeah, of course, you have to be. It's an enum. Makes sense. Okay, makes sense. So I was here. Offset off. Comp time type, comp time field name. So comp time, and then a slice of constant slice of U8s. Comp time integer is the return value, returns the byte offset. Offset off, okay, of a field relative to its containing struct. Byte offset of a field. Nice, nice. So this is all low level stuff. Call modifier, std built-in call modifier, function, any type, args, any type. So this is receiving a function, arguments for that function, and then the modifier, which changes the call. It returns any type, calls a function the same way that invoking an expression with parentheses does. Let's see the example. So try expect call dot auto, that's the modifier, right? Add is the function, and then arguments are 3 and 9. So it will add 3 and 9. So makes sense. And what the modifier auto does, I'm not sure. And then they have this function add, which takes these two parameters here, and then returns i32 and returns a plus b. I'm just not sure what this auto means, what this modifier actually does. Call allows more flexibility than normal function call. Syntax does. The call modifier enum is reproduced here. So let's see what is there. Here they'll explain. Equivalent to function call syntax auto. So this is the equivalent to function call, okay? Async kw, equivalent to async keyword. Okay. So this is like literally you have async in front of the function. Prevents tail. So now they're speaking about this one. Prevents tail call optimizations for this one. This guarantees that the return address will point to the call site as opposed to the call site's call site. Okay. Yeah, so if it's nested, it will just take the original one or the last one. Let's point to the call site. Yeah, the last one. If the call is otherwise required to be tail called or inlined, a compile error is emitted instead. Okay. Then this one never inline guarantees that the call will not be inlined. If the call is otherwise required to be inlined, a compile error is emitted instead. Okay, no async. Asserts that the function call will not suspend. This allows a non-async function to call an async function. Guarantees So now it's always tail. Guarantees that the call will be generated with tail call optimization. If this is not possible, a compiler is emitted instead. Okay. Always inline. It's kind of like the opposite of previous one. Inline and at call site. If this is not possible, compile. Yeah, this is the opposite. Compile time. Evaluates the call at compile time. And again, error if it's not possible. Okay, C define. So I guess compilation support for C integration. So it receives two things: the value and a constant slice of U8s. Returns nothing. Function can only occur inside of C import. So C define C import. Okay, so you have to first do the C import, which is probably after, yeah, here. And then you can use this one to define. Okay. This appends the define name and value to the import, C import, temporary buffer, to define without a value like this. Use the void value like this. Okay, yeah, this is the void. I remember this. I use this as a void. C import expression type. So it returns some type, which is determined in the compilation time. This function parses C code and imports the functions, types, variables, and compatible macro definitions into a new empty struct type, and then returns that type. Okay. So this is interesting. This is how you integrate with C. Expression is interpreted at compile time. The built-in functions include and define and C undefined work with this expression appending to a temporary buffer, which is then parsed as C code. Okay. Usually you should only have one C import in your entire application because it saves the compiler from invoking clang multiple times. Yeah, makes sense. And prevents inline functions from being duplicated. So if they say you should, probably means that you still can use this multiple times, that it will compile still depending what you do, but that it's not recommended. Okay. Reasons for having multiple C import expressions would be to avoid a symbol collision. For example, if foo headers file and bar both define connection count. Yeah, okay. To analyze the C code with different preprocessor defines. Okay, CLN include. No, this is C include. Okay, yeah. Sometimes it's hard to read and to see if this is. So that's why I kind of like prefer the fonts that have, like the two lines above and below, so that I can easily see if it's L or capital I. Yeah, like this one. So include comp path, again, constant slice of U8s, doesn't return anything. This function can only occur inside of C import. This appends include and then the path to the C import temporary buffer. Okay, CLZ, any type as parameter, any type returned. Type of operand must be an integer type or an integer vector type. Operand may be an integer vector, counts the number of most significant, leading in a big endian sense, zeros in an integer, count leading zeros, CLZ. Okay, the return type is an assigned integer or vector of assigned integers with the minimum numbers of bits that can represent the bit count of the integer type. Okay. If operand is 0, CLZ returns the bit width of integer type t. Now oops. Yeah, okay. CMPX change strong. Oh, let's see first what it receives. One type. one pointer to the same type, expected value of that same type, new value of the same type, success order of the atomic order, so the thing that we've seen above, and fail order of the same atomic order. And then optional T. This function performs a strong atomic compare and exchange operation, returning null if the current value is the given expected value. It's the equivalent of this code except atomic. Okay, the signature is the same. All value, if all value is equal to expected value, then the value of the pointer is a new value. So they have the all here. They set this to new, return null. If it's not the expected value, they return the old value. Okay. Okay. If you're using complex change in retry loop, this version weak is the better choice because it can be implemented more efficiently in machine instructions. T must be a pointer, a bool, float, integer, or enum. And the alignment must be greater than size of T. Atomic order can be found. Okay, this is the same like before. This is the weak that they referred to here. So I guess the similar or even the same signature. It looks like the same signature. This function performs a weak atomic compare and exchange, returning null if the current value is the given expected value. It returns null if the current value is the given expected value. It's the equivalent of this code except atomic. Okay, so that's the difference. Here, if it's... Wait, this is the same. What am I missing? Const all value equals pointer star. Const all value equals pointer star. Ah, okay. Usually true, but yeah. Okay, it's so big that I missed it. So they have this additional condition here. Using complex change is retry loop. The sporadic failure will be no problem, and complex change weak is the better choice because it can be. Yeah, so this is kind of like a shortcut, like when you do the bitwise and or. So in some language, if you have like 2 times the character or once, so one is the short circuit version of it, so it will not check the other if the first one is true. This is kind of the similar, so you expect this one to almost always be the true one. Let me see what you wrote. These atomic operations are needed for the low-level stuff, but you generally don't work with them. Okay, and it choice because it can be implemented more efficiently in machine instructions. However, if you need a stronger guarantee, then the strong can be used. Same restrictions for the types. Okay, compile error. Receives a constant slice of U8, no return. This function, when semantically analyzed, causes a compile error with the message MSG. There are several ways that code avoids being semantically checked, such as using if or switch with compile time constants and comp time functions. Okay. So then compile log. So I'm still at C. Yeah, no way I will do the entire alphabet here. So let me think, what should I do? Because I already spent like maybe even 40 minutes and I'm still at C. So if I wanted to go through all of this, it will simply take hours. And I don't want to do that. Let me see how many things are left. So we have build mode, single threaded build. So they are both related to build. So I even cannot do this until I install locally. Okay. Illegal behavior. And it looks like a large part memory. Compile variables, compilation model, Zig build system, C WebAssembly target style guide. Yeah, so probably not a good idea that I continue in this rhythm. So maybe not to analyze the rest of them, I will just quickly go through. I will not read all the details. I'll just maybe read the first line here that should explain what it does, and that's about it. Aha, okay, yeah, that's even better. You can just like suggest, recommend which ones I can focus on. Thank you. Or let's say the ones that probably most of the people will need. So if you're not doing something very specific to a topic, some of them that are, let's say, used by 80% of the people or something like that. Div, okay, let's find the div. Where is the div? Div c d d d d here. Div exact. Div exact numerator t, denominator t, so the same type. The result is the same type. The return type is the same type. Exact division. Yeah, it makes sense that they call it exact and that they do exact division. Color guarantees denominator is not equal 0. Okay. And div trunk nominator, how you pronounce it, and denominator times denominator equals numerator. Yeah, sorry, I'm blind. Div exact 6,3 is 2. So if you divide 6 by 3, it's exactly 2. And a so if you do this times b equals a, right? So if the result is multiplied by b, you are getting a. That's the point. Okay. The floor, same signature. Floor division rounds toward negative infinity. Okay, for unused, unsigned integers, it is the same as numerator slash denominator. Color guarantees that, again, denominator is not equal to 0. And type of t is not equal to int. T is signed and numerator equals to standard math minimum integer and denominator equals -1. Okay, this is just for these like extreme values so that you don't get in the overflow. So let's see here, -5 divided by 3, but the floor division, so it's -2. Okay, so it will be 2 point something, right? But not actually, in this case it will be less than 2, but it's rounded up down. So the floor AB times B plus equals, yeah, so this is just like a fancy way of saying this. Let me see what else you said. Div once embed file in okay, thank you. I actually have one more div trunk here. Let me just finish this one. So the same signature, truncated division rounds towards 0. For unsigned integers, it is the same as numerator slash denominator. Color guarantees, so again, it's easier to see the example. So this one goes up, let's say, to simplify, and this is just like to test if the opposite works. Okay, let's see what Robert suggests that we cover next. Embed file. This is the one. Okay, perfect. So it receives a path on time variable, which is not actually a variable, but constant slice of u8s, and it returns the pointer, the constant pointer, to, I think this is a zero terminated array of size n, right? U8s. This function returns a compile time constant pointer to null terminated fixed size array. Okay. So a compile time constant pointer. Okay. To this fixed size array with length equal to the byte count of the file given by path. Aha, yeah, because it's embedding the file. So it will count how many bytes are in the file, and that's what is going to be inserted into this array. The contents of the array are the contents of the file. This is equivalent to string literal with the file contents. Yeah, I was thinking about how you work with files in Zig for the next project. Maybe it would be interesting. So embed file, the built-in. I will try to memorize. Pet is absolute or relative to the current file, just like import. Okay, just like import. Let me see what else. Enum from int. Enum from int. So this one. Okay. Converts. Let's first see the signature integer any type. Any type. So receives integer of any type. Any type as the output. Converts an integer into an enum value. The return type is inferred. The inferred result type. Attempt to convert an integer with no corresponding value. In the enum, invoke safety checked illegal behavior. Okay. So of course you cannot target something that doesn't exist in the enum. Note that non-exhaustive enum has corresponding values for all integers in the enum's integer tag type. The underscore value represents all the remaining unnames. Yeah, this is what I played with when I tried to do a switch on U4. I think I tried, and then it was enough that you cover 0, 1, 2, 3, and it was exhausted. Okay, let me see the next one. What Robert suggests: error name. So this one, the signature is the any error as the input, and the output is a constant. What is this slice of or array slice? Or array, looks like array. So zero terminated array, constant of zero terminated array of U8s. This function returns the string representation of an error. The string representation of error out of mem is out of mem. If there are no calls to error name in the entire application, so if there is no call to this built-in, or all calls have a compile time known value for the error, then no error name table will be generated. Otherwise it will. Okay. Let me see what is the next one that Robert suggests that we do. Field. Okay, let's do a field. Find it here. Field has the signature LHS, any type, comp temp field name, which is again slice, a constant slice of U8s, and it returns the field inside the parentheses. So I'm confused what this is. A parenthesis just like around this field. Let's see. Performs field access by a compile time string, works on both fields and declarations. Let's see the example. So they have this struct, which is they call point, which has these two fields. You returns both of them. One is x and the other one is y. And it also contains the no, this is not a function. I was about to say the function because it was looking too large, but actually another field, z, which is in this case public, and it's variable, and it's U32 set to 1 by default. Then they have these two tests, field access by string. So they have var p, which is point with these two fields set to 0, and then they don't have to set this one because it has the default value. Then they have this at field built-in call, and they pass the p and the string x, okay, and they say equals 4. So so this basically returns the field itself, the reference to it, or however you want to say. So maybe not the correct to say the reference, but because you can assign the value, so it has to be dereferenced. Then The next time they do a similar thing for y, they select the y field, but then they, okay, they just have it in expression on the right, so they have now the field p of x to access it, but this time they read from it. And then add +1 to it, and then this result is assigned here, okay? So then we can even try to figure out how, if this is correct. So I guess it is, since it's in docs, but just to play a little bit. So first they set x to 4, which was set by default to, not by default, but here it was set to 0. So now x becomes 4, then y becomes 4 plus 1. Yeah, so that's what they said. And the other one, declaration access by string. The ECL, I guess it's declaration. So they, okay. They just read it and they ask if it's 1. Then they change to 2 here and they ask if it's 2. Okay. Let me see the next one. Field parent pointer. So this is the one. Receives a field name, which is a const slice of U8s, and field pointer, which is, of course, the type is pointer to a type, and returns any type. Given a pointer to a struct field, returns a pointer to the struct containing that field. So you get the struct field, but you don't know exactly in which struct it is, and then you get, yeah, we use this one. I remember using this one in some previous days. I forgot where, but I think I used this one. Okay, the return type and struct in question is the inferred result type. Okay. If field pointer does not point to the field name, okay, so it can be of that type, but it doesn't point to the name field of an instance or of the result type, and the result type has ill-defined layout, invokes unchecked illegal behavior. Okay. Field type. Is this the next one? Give me just a second to see. No. So we have float cast and float from int. Okay, let's do those. Where are they? Float cast here. So this one receives any type as the value and returns any type. Convert from one float type to another. This cast is safe, but may cause the numeric value to lose precision. The return type is inferred result type. Okay. May cause the numeric value to lose precision if you go down. That makes sense. One question, Robert. I was thinking about this. So when they make any type as the return type, and in this case, for example, they want to cast float from one to another one. So you could technically create here the union of all the floats, for example, and it would be the same. So you can do that, right? So they just like use this like as a more elegant solution because you see any type and they don't expect you to actually receive something that is not a float, right? If I understood correct, because they say convert from one float type to another. Do they mean like another float? Another type, not float type. Okay. Yeah, this can be ambiguous. Okay, now it makes sense why it's any type. So you receive the float, but you cast it to any other. Not really any type is single specific type. Okay, yeah. Okay, the next one that you recommended is, where is it? Float from int. Float from int. So this is, it's just known, so Robert explains further. It's just known as at compile time based on what it returns. or takes in. Yeah, it's the comp time thing. Okay, thank you. Yes, still confusing some things. What I said, the next one is float from int, I think. Yeah, this one. So it receives integer of any type. Yeah, so like basically like type is also a comp time type. Yeah, I was also confused before with this type when they say type as the type. But then when we did comp time, then it made sense. So integer is the any type, and it returns also any type. Converts an integer to the closest floating point representation. Okay, yeah, that makes sense. The return type is the inferred result type. To convert the other way, use int from float. Yeah, this operation is legal for all values of all integer types. Yeah, because it's passing to the larger type, to more precise type. Let's say like that. I mean, still not precise because you have the way of how you represent floats in computer science, like as the approximation. So you can have some loss of precision, but yeah. So let me see what is the next one that Robert suggests. Has the ECL, has field. Let's do those. H is FGH here. So has field, no, has the ECL. So let me just see which are, yeah, these are two next to each other. So let's do has declaration, obviously. So from time container of the type is the first parameter, and then the second one is constant slice of U8s, and it returns boolean to say if it has declaration of or not. It returns whether or not container has a declaration matching name. So let's see the example. Const foo is a struct, nope is i32, public variable blah, which is xxx, as string literal, and then const high is 1. Then they ask if who has the declaration of blah, and they all pass. So this test, I mean the only test that they make, but these 4 things pass. That's what I wanted to say. So yeah, here it's defined. Blah is defined. Then I is not, but why? Even though high is private. Sorry, I'm blind. Yeah, high is here. Has declaration returns true because this test is in the same file scope. Okay. So yes, of course it sees it. Okay, then the next one is nope, and the next one is nope 1, 2, 3, 4. So nope is this one here. As declaration is for declarations, not fields. Nope 1, 2, 3, 4. They invert. So I was confused like how this passes if it's not for fields, if it doesn't check fields, but I missed the negation part. So then, of course, it is true that there aren't these declarations here on the right side. Okay. Has field is the next one, right? Yeah, has the field. Has again container type as the first parameter, and the second one is the same like previous, and boolean is the same. Returns whether the field name or of a struct union or enum exists. So this is like the other one, the complementary one. The result is a comp time constant. It does not include functions, variables, or constant. Okay. So this is about the field name. Then I think the import is the next one. Yeah, and then int cast. So import has one parameter, sorry, which is a constant slice of U8 called path, returns type. So it finds a zig file corresponding to path and adds it to the build if it is not already added. Zig source files are implicitly structs. This is nice to know. So zig source files only. With we already seen how when you load the file as an array. So that was the second example where you, let's say, want to read from the data file, and you read it like kind of like a string, literally in the same way. So it's an array, but if it's a zig source, then it's struct, I guess, because it's easier to parse. With the name equal to the file space name, with the extension truncated. So the struct will have the same name without extension. Returns the struct type corresponding to the file. So it will be of that type, okay? Declarations which have the pub keyword may be referenced from a different source file than the one already they are declared in. Okay, so this also makes sense to organize the visibility and avoid conflicts and so on. Path can be relative path, or it can be the name. It can be also name of the package. If it's relative path, it is relative to the file that contains. Yeah, I mean, that makes sense. That's usually the case. So to the file that imports the file. The following packages are always available. Okay, so they want to say it doesn't have to be, of course, in the same file where you write the code, because they are the global ones, let's say. So the standard library, the built-in, target specific information, the command zig build exit show built-in outputs the source to std out for the reference. Okay, and the root source files, this is usually main zig, but depends on what file is built. Okay, then int cast was the next, I believe. Receives the variable called int, which is the type any type, and returns the same type. Converts an integer to another integer while keeping the same numerical value. The return type is inferred result type, attempting to convert a number which is out of range of the destination type results in safety checked illegal behavior. Yeah, we also tested this. So they set variable a to U16 this hexadecimal value, and because it's 16, so it has like 2 bytes, right? So 4 hex digits, so it should be fitting in. No problem there. Then they dump the a to the underscore, but then they have this problem that they try to cast a into a single byte, and that's of course impossible, so this will break. Okay, nice. Let's see what is the next one. In from just read their names. Okay, let's go. So in from bool, in from enum, in from error, those are also available, which are pretty self-explanatory. Let's see the next ones. Max, mem copy, mem set, min mod. Okay, we are at the M. Here L. Wait, these are. It's not completely in the alphabetical order, but close to it, where it was mem. Here M. Here. So what was the first one? The first one was max, right? Yeah. So max is this one. Takes 2 or more arguments. That's why they say 3 dots here. And returns the biggest value included, the maximum. This built-in accepts integers, floats, and vectors of either. So vectors of floats and vectors of integers. In the latter case, so the vectors of floats, the operation is performed element-wise. NANs are handled as follows. Return the biggest non-NAN value included. If all operands are NAN, return NAN. not a number, yeah. So yeah, this is in most of the languages NaN is float. Okay, so this one is pretty straightforward. The mem copy, that's the next one. So it has no alias destination and no alias source as inputs, and void as one doesn't return anything. This function copies bytes from one region of memory to another. Yeah, copy. But this is literally like so low. I've seen this also, for example, in Solidity. When you work, you can do similar things. But you actually kind of make the assembly that you can call from Solidity can do something like this. So not directly. There is no mem copy function that is built in. You have to go down in assembly. Just a fun fact. Let's focus on Zig. So this function copies bytes from one region of memory to another. Okay, destination must be mutable slice, a mutable pointer to an array, or a mutable many item pointer. Yeah, this was the word I was looking for like half an hour ago. Not the word, but the expression, the name. It may have any alignment and it may have any element type. Okay, source must be a slice, a pointer to an array, or many item pointer. It may have any alignment. So that explains what can be source, what can be destination, and then similar to for loops, at least one of the source and destination must provide a length. Makes sense. And if two lengths are provided, they must be equal. Again, makes sense. Let's see, memset, then minimum and mod are the next. Minimum and the mod is not here, but oh, there's something about WebAssembly. WASM, memory grow. That's cool. Memset, destination element, are parameters. Void is the return type. This function sets all the elements of a memory region to elem. So sets all the elements of a memory region to elem. Destination must be a mutable slice, mutable pointer to array. It may have any alignment and it may have any element type. Elem is coerced to the element type of destination. Okay, for securely zeroing out sensitive contents from memory, you should use this one, crypto secure 0. Okay, then yeah, this is just like if you want to set the part of the memory. Then we have minimum, again multiple. Yeah, so very similar to maximum. So it takes more arguments, 2 or more arguments, and the same rules apply like for the maximum. So the smallest non NaN value, and if all are NaN, then it returns NaN. Okay, and then the last one was, there is let me see just the comment, sorry. First of all, yeah, the Andre answers. There is also mem move now, but it is on master docs. So it's not mentioned here. So then we can guess what it does. So it takes a part of a memory and then moves to another part. Let's see what is the next one. Mod. This one. Modulus division. Okay, so it takes two things of the same type, returns the same type. So 2 inputs, 1 output. Modulus division for unsigned integers. This is the same as using the modulus operator. Polar guarantees denominator is greater than 0. Yeah, because you cannot divide. Otherwise, the operation will result a remainder division by 0. Okay, when runtime safety checks are enabled. Only when it's enabled in the runtime. So they give an example, and this is the opposite operation that proves it. Okay, It's same as memcopy, but regions can overlap. Regions can overlap. Thank you, Andre, for explaining. Yeah, that can be useful. So this is a new one, right? So this is something that they are introducing it into 0.15 version, or it also exists in 0.14, but they still haven't added it here into docs. And let me see what is the next here. Panic pointer cast, pointer from integer size off. Panic pointer cast, then pointer from int. Then so let's do the p. So panic pointer cast, pointer from int. Those three, okay. Panic receives one constant slice of U8s, and it has no return as the return value. Invokes the panic handler function. By default, the panic handler function calls the public panic. The public panic function exposed in the root source file, or if there is not one specified, the standard built-in default panic function from here, from the standard library built-in. Generally, it is better to use debug panic. However, panic can be useful for two scenarios. The first one, from library code calling the programmer's panic function if they exposed one in the root source file. Okay. And second, when mixing C and Z code, calling the canonical panic implementation across multiple .o files. Okay. Then we had pointer cast, I believe. It takes one parameter as an input of any type and returns any type. Converts a pointer of one type to a pointer of another type. The return type is the inferred result type. Again, result types here. Optional pointers are allowed. Passing an optional pointer, which is null, to a non-optional pointer invokes safety check illegal behavior. Again, expected. Pointer cast cannot be used for removing const qualifier. So for that, you have to use const cast. Removing volatile qualifier, again, volatile cast instead. Changing pointer address space, which in that case you want to use this one, address space cast, sorry. Increasing pointer alignment, in which case you should use align cast, and casting a non-slice pointer to a slice using slicing syntax. Okay. And then pointer from integer. This one takes one parameter, which is uSize. So architecture specific, which is the address, which makes sense that it's then architecture specific, and returns any type, converts an integer to a pointer. The return type is the inferred result type. To convert the other way, you have the opposite built in, casting an address of 0 to a destination type, which in not optional, and maybe they want to say which is not optional and does not have the allow 0 attribute, will result a pointer cast invalid null. Yeah, makes sense. So it's not optional and doesn't have allow 0. Then you cannot use 0 to make a pointer. Okay, then let me see size of. Yeah, size of is the next one. Size of takes one generic compile time type and it returns comp time integer. This function returns the number of bytes it takes to store that type in memory. The result is target specific compile time constant. This size may contain padding bytes. If there were two consecutive types in memory, the padding would be the offset in bytes between element at index 0. Yeah, that makes sense. And the element at index 1. For integer, consider whether you want to use size of t or type info t int bits. Alternative. Okay, let's see the next one. Really important ones. This type info, type of, and vector. Okay, let's start with this. This one. This, which is empty, so takes no input parameters, and has no input parameters, so maybe it's better to say, more correct to say, it takes no input arguments, has no input parameters. Type, generic compile time type is returned, returns the innermost struct, enum, or union, struct in union, that this function call inside. Call is inside. So that this function call is inside. So if you have this built-in function call from, let's say, struct, which is in struct, which is in enum, then the first struct that I mentioned is this, okay, and so on. So the most nested one, right? The innermost, how they say. This can be useful for an anonymous struct that needs to refer to itself. Yeah, makes sense, because otherwise you would not be able to refer to itself. You wouldn't say this because it doesn't have a name. Let's see the example they provide. So they have variable items, which is an array of i32s with these four elements. So at comp time size 4, const list, which is here is what they define as a list. So let's first go through the list quickly. So this list is a function that takes a comp time type t and returns the same type and returns the struct of 1. So self equals this. Okay, let's see first what they do here. They create a constant instance of self, which is this of this struct, so anonymous struct, and then they call it self here. Then in this other one they have items, this other field, and it's slice of t, right? And then the function is the third thing in this list, in this struct actually, sorry, which is called length, and it takes the self and returns usize, and then takes the self.items.len. So the self.items and then the length of this. Okay. Then what they test, I forgot to finish this. So const list, they take this list, they pass i32 as a type, and then they return the so if I'm not mistaken, what happens here, this will return this struct, and then here they will take the items of that struct and then set the value to these items. So they slice from the beginning to until the end, and then they try to see if the length equals to 4. Okay, and because these items here, I mean, this is referring to the items from here, and these items is referring to these items here. So they take the returned struct, then access the items field of it, and then they set to this, what is from here. And that's why it's 4, because this one has 4 elements. Okay, let me see what you guys wrote. Hi trader detective. Hi trader detective. I like a cryptocurrency or some other pie. Hello, hello. Finally, I caught you live. Welcome. Great to see the videos got specific titles now. Yeah, I listened to the suggestion made before. Yeah, I kind of like had it as a placeholder, and I thought I'm going to have it like only for the first video and that for the first stream, and then after I figure out what I will talk about, that I will change immediately. But then I completely forgot, and I just like copy pasted, copy pasta problem. Let's see what Andrew said. Self thing is not used anymore. Just put at this. Directly. As type in function definition or specify type directly. So you want to say here that you don't say anymore the uppercase self. You would rather do this thing here. Okay. So now use this built-in. Okay. Let's see what they say here as the final point here. When this is used at file scope, it returns a reference to the struct that corresponds to the current file. So that's because you basically have this, how it's called, I already forgot, the import, yeah. So the import built-in makes this struct, and this is what they refer to. It returns to a reference to the struct. So I just like combine it with the import. That you don't, of course, you don't have to import. You can have the root file that you're writing, the main one. Doesn't have to import anything, and I mean that file doesn't have to be imported, and you will still have this referring to it. Okay. Let me see. Yep, Andre confirmed that this is how you should use at this instead of self. Thank you, Andre. Let me see what was the next one after this. Type info. That's the next one. Comp time t is the only input parameter. So compile known type. Standard built-in type is the return type. Okay. So type info. So they will just, of course, use the standard types to give you the information that this is of that standard type. Okay. Provides type reflection. Type information of structs, unions, enums, and error sets has fields which are guaranteed to be in the same order as appearance in the source file. Okay. So the same order as in the source file. Type information of structs, unions, enums, and opaques has declarations which are also guaranteed to be in the same order as appearance in the source file. And opaques has declarations. So in this case it's fields, in this case it's declarations. Okay. So we used this also before, I remember. Thanks, Robert. Let's see. The next one is type. Just type. Okay. So here, this one. Type takes one parameter, which is called info. It is comp time known, and this is again the same type that we had before, the built-in one. So it has to be of built-in one, built-in type, and it returns this generic type. This function is the reverse of type info. It reifies type information into a type. It is available for following types. Type, no return, void, bool, integers, floats, pointers, comp time into comp time float, type of undefined, type of null, RS optionals, error set type, error union type, vectors opaque and frame, struct enum, enum literals, union, and functions. Okay. So you provide the built-in type and you return the type. It reifies. A very weird word. Reifies. Reifies. Okay. The next one, where we were here, type of. Or didn't I do type of now? No, I did type info, yeah. So type of this one. So now we already went with two built-ins that had the same signature, so two and more, right? Yeah. Ah, no, this one it's expression. It takes any non-zero number, any number of expressions, yeah. So similar to what we had before. So it takes any non-zero number of expressions. So it has to be at least one expression, but it can be any number of expressions. And it returns the generic type. Parameters, okay, and returns the type of the result using the peer type resolution. So this is what we went yesterday or the day before. The expressions are evaluated. However, they are guaranteed to have no runtime side effects. Okay, so they have here the example. They set the variable data to i32. They set the variable which is i32. They call it data. They set it to 0. Then constant of they call it t. So they then take the type of built-in. They call it, and they call this function inside of it. And they pass in i32 and the reference to the data here as parameters, so it's as arguments. So let's see what they do with it. So this foo has two parameters, comtime t type and pointer to the same type, and returns the same type. And what it does, it will dereference the pointer and take the value from it and increase by 1. So the pointer is this one here. So the data, in our case, 0. So it will be plus 1, 1. And it returns the pointer of, so in this case, of course, it's i32. I failed to mention that, but it is i32 in this case. So it will return the i32 of with the value of 1. So this will be 1. And then you get the type of 1, which is i32. So then this will be the i32, right? Will be the type. And then they expect, yeah, to see type as i32, and the data is 0. Okay. That one is clear. Let me see what you guys wrote. Robert says you already used some type info. It's great. Yeah. I remember this. That we used, and then we accessed some child fields or nested structs. I forgot what was it. Type allows you to build stuff like enums at compile time. It generally said to limit such time building, but at small scope, it's great. Type building, yeah. Thank you, Robert. Let's see what's the next one. The next one is vector. This one. So this one has two parameters. One is called len, which is comp time integer, and the other one is called element, which is the generic type and returns the same type. Rates vectors. Plain and simple. Okay. Nice. I love this explanation. Yeah. That is all. There are some math operations. I'm reading now the previous Robert's message where he recommended which built-ins to cover, because there are so many of them. So this would literally take 5 hours to go through all of them. So the math operations like log 2, log 10, sine, cosine, and so on. But those are kind of intuitive. Yeah, so yes, I agree. It's kind of understood what they do. So they're built in. Let's just like take a look one of them. For example, let's do log 10. That's the most common one. I mean, in programming also this one, but in math, I would say log 10. log 10 takes as the input a value, which is any type, and returns the type of that value, returns the logarithm to the base 10 of a floating point number, uses a dedicated hardware instruction when available. Okay, hardware dependent. So it will leverage if there is a specific instruction set supported by hardware. Nice. And then we had the sign. Let's just like click sign as well. Yeah, they're literally explaining them in the same way. Uses a dedicated hardware instruction when available. Yeah, I remember this sign. For me, it was very interesting when we did math at my university. So when we used, I think in English it's called order. So because I learned it in my language, Serbian, so we call them redovi. So I believe the English equivalent is orders in math. So when you create like, you know, like the rhythmical thing that is changed over time. So you have basically never-ending polynomial, if you will, expression, and then the more elements you add, it is more precise. So you know exactly how many decimals you need to get some certain level of how many expressions you need to have a certain level of precision. Like if you want 10 decimals precision or more or whatever, you know exactly for each of these functions like sine, cosine, all these trigonometry and much more. This was like very cool to understand, because I was wondering how they did this in coding before I learned it in math, and then when we learned in math, it was like so cool that you can actually simplify all these functions in series of additions, and I think you also divide things. So, but basically multiplication, division. Yeah, so that would be probably it for today, because I'm already 1 hour and a half into the stream and I started late. So I mean, I don't have problem. I have problem sleeping anyway, so I will not sleep soon. But for the guys that are in Europe here, probably not a very nice thing to have the brain working so late. Then I know for you guys, but if I do a lot of thinking anyway, like if I do coding or if I just think about problems, solving like logical problems or things like that, then I cannot sleep. Like my mind gets like stimulated, and then I have trouble falling asleep later. Switching off the brain. Let me see if you wrote something. Click it, the vector. Aha. Yeah, sorry, I just saw now. Vectors. Vector is a group of booleans, integers, floats, or pointers, which are operated on in parallel using SIMD instructions if possible. Yeah, I remember this was also like one of the things, if I'm not mistaken, because I have never done, for example, I never did game development other than, yeah, I did some Pygame projects and things like that, but serious game development like C++ and things like that, where you actually code the 3D graphics, I never did it. So if I'm not mistaken, this is when you can use the magistral to parallel access the pieces of memory so that you can speed up things, so that you can basically do it in parallel. If I'm not mistaken, maybe it's a different acronym, but I think it was the single instruction, multiple data. Yeah, this is, I think, the thing. So I learned about it just like theoretically when we were learning about the hardware and how it works. I think this is, if I remember correctly, it was a long time ago, but I think this is like how graphic cards work. So not maybe necessarily, I haven't followed, maybe they even do something similar in the regular, like regular processors and regular memory, not only like the GPU and the memory bus there. Let me see what you guys say. Count some sheeps using for loop. Yeah, that would help. That would probably start like, should I make a while for, oh, I can have a capture group, and then my mind would drift away to a completely different topic than a loop. Like always. So let's see what they say here. I'm SIMD instructions. If possible, vector types are created with the built-in function, this one. This is cool, like this one refers to this one, and then you click, it refers to this one. An infinite loop. Vectors support the same built-in operators as their underlying base types. These operations are performed element-wise. My mind completely stopped if I think I didn't cover vectors before. Where they are here. I think I just like saw that they are referring to something like this and built-ins and that I skipped them, but I completely don't remember if they seem unfamiliar, so they look like I skipped them previously. What are they? Destruction array. So definitely I did this. Yes, I did this. Okay, support the same built-in operation as their underlying base types. These operations are performed element-wise and return a vector of the same length as the input vectors. This includes the arithmetic operators, plus, minus, slash, like division, multiplication, div floor, square root, ceil, logarithm, etc. Bitwise operators, all of them. Comparison operators. Okay, it's prohibited to use a math operator on a mixture of scalars and vectors. Yeah, that makes sense. Zig provides the splat built-in to easily convert from scalars to vectors, and it supports reduce. This is like the regular, I guess, like functional programming reducer, and array indexing syntax to convert from vectors to scalars. Yeah, okay, so splat is from scalar to vector, and they use the reduce to do the opposite. Vectors also support assignment to and from fixed index, fixed length. I love when I don't even look at the word. I imagined like the one that I like. From fixed length arrays with comp time known length for rearranging elements within and between vectors. Zig provides shuffle. Now, okay, that's cool. And select. So I guess this is like not cryptographically safe, so maybe you can use it for some game or something, but maybe not cryptographically safe. So I would actually have to see if they say something. So I would just want to see quickly if it's cryptographically safe. They don't mention it, so that I can see quickly. Okay, back to vectors. Operations on vectors shorter than the target machine's native SIMD size will typically compile to single SIMD instructions. Okay. While vectors longer than the target's machine native SIMD size will compile to multiple SIMD instructions. This is so cool that you can literally like use the hardware if you can. That you can use the hardware support. This could be potentially also very interesting for this AI hype that they have, because they use graphical cards for all these calculations, and they use mostly, as far as I am familiar, like how most of the people are doing it, they're using Python libraries that are written in either C, maybe some of them are even in Zig. I'm not sure. I know, for example, some of them that I used are written in C. And this can be very, very interesting, that you can experiment with these data sciencey thingies. If a given operation, I've read this, Zig supports any comp time known vector, length up to 2 to the power of 32 minus 1. Although small powers of 2 to 64 are most typical. Note that excessively long vector lengths, like 2 to the power 20, may result in compiler crashes on current versions of Zig. So they're probably going to improve that in time. To talk about CABI interop, destructuring vectors. Okay, so I don't want to speed up things. At least I've read through this part here, and I don't want to make this like 2-hour video, which is like, it looks like it's heading to that length. So I will maybe do this tomorrow. This seems like very interesting thing. So tomorrow I can read through this code, see how they actually use vectors and then destructuring vectors as well. And then this is the part that I already did. So for sure I will finish vectors tomorrow, actually do them because I haven't touched this code. I've just read the theory, the theoretical part, because it was related to this built-in vector that creates them. And yeah, I think I'll stop here. Let me just see if you had, no, you haven't wrote. Now Robert writes something. Well, that is basically all on built-in. Yeah, so this is like humanly possible, everything about built-ins, that if we don't want to make this like 5-hour video and go deeper, but it's I think it's the ones that we went through today are pretty much the most commonly used, right? Ones that someone will need for most generic use cases. And at least now everyone has a idea what is there and what can be done. And I also have some ideas, for example, what I can now do. So for example, the next project that I will use as a practice one instead of tic-tac-toe can be like this 4 inline, I mean n inline, let's call it, or z inline, zig inline elements with gravity. But we can play so that I can maybe save files and save the state of the board into a file, and that I can also load them so that you can maybe play with like theoretical multiple people and save if one becomes very long, one game becomes very long, and so on. So this is the idea. Then I can use this file. How it was called, I already forgot. The one that loads the file, not the import, but the one that loads your there is the file, I think, in the name. Let's try to embed file. Yeah, this one. So I will probably use this one so that I can do what I just said, so that I can read the state of the game from the file and write into file as well, or maybe even some statistics like to play with, like I don't know, this game when it's finished, like I can maybe even store every move. So like player one plays, you know, like in chess when you read how they play chess, they say like the first move, the second move, so it's kind of like a list of all moves. So maybe I can also do that just to play, of course, so not that I need, but just to play with writing into file, reading from file, and then processing things in Zig. This could be a nice additional, and of course for this I have to install locally. Finally. Yeah, sounds like a plan. It was very interesting. And let me see also after the vectors, what would be the, so build this is really depending, it really depends on my setting up the local system, so the local Zig. So I will have to do it after I install. Then let's see the illegal behavior. How long? Yeah, this is very long. Memory. Choosing an allocator, where the bytes. Just trying to see if for tomorrow what I can do, because I think I can finish vectors quickly. So population model. Yeah, this is a larger Zig build system. Again, build. I guess. Okay, and compilation time. So yeah, now everything basically depends on running Zig locally. Style guide. Oh, maybe you can go through the style guide. That sounds fun. White space. Yeah, cool. I can go at least to the style guide. This is interesting, and it's nice to know, so that when I code, I would love to have, let's say, a standard way of writing things as per the language, how the language is recommending. And this I think I can finish along with vectors. So then probably tomorrow vectors and these style guides. That was so one easier day after today's a bit harder to follow maybe day because we covered so many things. Let's see what you guys wrote. Python Detective says Zig makes SIMD easy. Yeah, I'm really thrilled to see that it's supported by the language itself. That it looks like it's very easy to use, much easier compared to writing it in C. Yeah. So then then I guess there will be a bright future for some game engines and alike in Zig. So maybe something like next Unreal Engine will be written in Zig or something. And will support Zig. Let's see what Robert says. SIMD in C is painful. Yeah, I can imagine. No, I wouldn't dare literally I wouldn't dare to do anything that is so complex in C today manually. Then Robert says embed file is placed into compiled code. There are runtime file reading tools. Aha, okay. Aha, this is the compiled. Yeah, built-in. Okay. Okay. So yeah, I will do a research for file reading. There is auto formatter in Zig extensions, so you will have standardized code structure at the very least. Aha. Yeah. So yeah, I still haven't worked on locally. So yeah, that makes sense. That there will be automated help. But also it's nice just to go maybe through it just to see what is and to compare it with maybe some other languages and to see what is the Zig way of doing things. More as a fun thing to do than actually. And let's see what is after the style guide, source encoding. This is also useful and nice to know. The keyword reference. Aha, they reference all the keywords. Okay, this is also cool. They have it here. Then appendix. Let's see. I'm just curious to see what is in appendix. Containers. Grammar. Yeah, this is interesting if you want to make some parse or something. Then, this is cool. Yeah, we can go also through this at least. When I go through the styles, it would be interesting maybe. Let me see what Robert wrote. It's the same as if you click format on the web playground. Yeah, I haven't even seen this. Like it's so huge. I didn't even. I just saw run, so my eyes did not see anything. Yeah, this is cool. Nice. So let me just try it quickly. Yeah, cool. Nice. Why I haven't seen this before? I did imagine. Okay. Yeah, when it's screaming at me, I don't see it. Thank you. Thank you for this. This is like so. I'm literally using it for 20 days and I never saw this. Like it completely went through somehow. Okay, I think I will wrap it up here, guys. Thank you a lot for being here today and for a huge help. Robert and Andrei, PyTrader, Detective. Thank you a lot, guys, for explaining things and being active. So tomorrow I will do a regular 22nd day 22, and I will do the things that I mentioned. So I guess I will be seeing some of you maybe tomorrow, some of you maybe some other day. Have a nice weekend and Saturday definitely, and see you next time. Bye bye.